we haven't really gotten into our textbook yet, but I wanted to just review these three types of averages because I'm sure you've all seen them before, and we kind of don't break it down so much in this course. What we do more is analyzing what do those three averages tell us about a piece of data, but we should know how we find them first. Okay, so here's a set of data, and when you have a set of data, you can do some statistics with it. So a statistic is just kind of a math computation that you do to a number that gives you a piece of information about the data set. So the three types of averages are mean, median, and mode. So here they are right here. Mean is when you add up all the numbers and then divide by how many numbers are added up. This is kind of the one that when people say, let's find an average, they always do the mean, but the mean actually is specifically the mean simply because the median and the mode are also two types of average. All right, the median is the middle number in a set of ordered data. So you have to put your numbers in order and then find the middle number. If there are two middle numbers, then we add them up and divide by 2. All right, and the mode is the number that occurs most often. Some data sets have more than one mode and some don't have a mode. So these three things together are three types of averages, and they have kind of a fancy statistical name, which is measures of central tendency. And that is because it's three ways to measure the center of a data. So if you have a set of data, you'd think that the middle is just the middle. And in statistics, you'll learn that the middle is subjective, right? The mean might show a different middle than the median, which might show a different middle than the mode. And so we kind of got to figure out why do we have three different ways to do it, and how do we know what's the best way to do it? All right, so this set of numbers right here is we're going to just find the mean of it. So that means we're going to add up all the numbers and divide by how many numbers are added up. Okay, so it'll look like this, right? We're just going to add up all these numbers, and there's 6 different numbers. So we're going to divide by 6. Even if there were some repeat numbers, you would put them in there and count them as well. Okay, so that's 55 on the numerator over 6. So in our calculator, we're just going to hit 55 divided by 6. And we're going to get an approximation of 9.17. That's what people typically call the average. Okay. The median. So the median is the middle number in a set of ordered data. Okay, so here's our data. We have to put it in order. And from there, we're going to go ahead and find the middle number. Well, as you can see, because there's 6 different numbers, then there is no exact middle number. But if it was an odd number of data points, then we would have an exact middle, and that would be easy. So the middle is right here. All right, and so we need to find the mean of those two numbers. I know this one's not too hard because 9 and 10, it's not very hard to go halfway between 9 and 10, but I'm going to go ahead and show it. So we're going to say 9 plus 10 and then divide by 2. 19 divided by 2, and that is 9.5. Okay, so the kind of interesting thing about the median is that sometimes the median is not in your data set. And the mode. The number that occurs most often is the mode. So in this set of data, there is no mode. No mode. And that is okay. The mode really becomes important when you have large sets of data, And the fact that you keep seeing some number pop up again and again and again and again tells you something about the data set that you are looking at. Okay, so now we'll go a little deeper. Those were just kind of the basics. So my question is, what if we took the biggest number in this data set and we took it out and we put in, say, the number 57? How would that change our mean, median, and mode? All right. So our mean would look like this, right? We're going to just replace that 14 with the number 57. And then when we add up all those numbers, we get 98 over 6. All right, so we have a new mean of 16.3. I'm going to go back. I forgot what the old mean was. Let me just look really quick. The old mean was 9.17. Okay, 9.17. All right, so there's quite a difference between the new and the old. Okay, the median. So we're going to find the median the same way. Now remember, this data point right here, we replaced with 57. Okay, does that change our median? Well, we still have our 6 numbers. That's still the halfway point. Our median is still halfway between 9 and 10. So our new median is 9.5. And our old median was 9.5. So there's no change in the median. All right, the mode. Oops, none. We didn't have a mode in the in the old data. I wrote it under the new. Changing this to a really big number doesn't change our mode either. So neither set of data is showing a mode right now. All right, so when you kind of put this all together, right? Here's where we had a big difference between our means. There was no change in the median, and there was no change in the mode. All right, so when you have a set of data where one of the numbers kind of doesn't really match all the other numbers, that number is called an outlier. Oops, there is an actual computation for an outlier, but outlier. We don't learn how to do that at this time, but when you're looking at a set of data, if you have one number that doesn't really fit the category of all the others, then typically that's called an outlier. And so you can see what an outlier does to the mean. An outlier always changes the mean. And this is called a skew. So when you talk about measuring the center of the data, skew, oh, darn it. When you talk about measuring the center of the data, the 16.3 isn't really, it's bigger than 5 of the 6 numbers in our data set, right? Whereas if you look at the old data, I'm going to try to circle the old data in green. Oh no. Okay, sorry, I have problems with my markers. The old data had the 14 in there, right? 9.17 would have been, that wasn't ordered, but 9.17, if we looked at the ordered data down here, would be also kind of between 9 and 10, right? So an outlier skews the mean, but it doesn't really mess with the median or the mode. And what the words that you'll see that go along with that concept are that the mean is sensitive to outliers. That means outliers can change the mean. It can skew your mean. But changing one number in a set of data even to change it to an outlier, it doesn't affect the median and the mode. Or if it does, happen to be change it, it would be slightly. And so we say they are not sensitive to outliers. Okay, so if you were absent, what I want you to do is answer the following questions on a sheet of paper and submit it following the submission instructions on the next slide. All right, so I'm just going to let it sit here for a minute. You'll have to pause and write the numbers out, and you're going to find the mean, median, and mode. And think about what is a better measure of the center and why. Would it be the mean or the median or the mode? What most accurately measures the center? Okay, and what could explain the much bigger wage that this one worker has, right? He's got a much bigger wage than all the others. Why do you think he would be earning so much more? Okay, so pause, write the numbers down, and I'm just going to go to the last slide here. When you're ready to submit it, follow these instructions. And again, you should be doing this if you were absent. I think on that second day of school. And so you missed our Google Slides activity and you missed the beginning of our statistics.